Around the world, more and more companies and more countries are trying to use hydrogen blended with natural gas to reduce the amount of carbon output or the greenhouse gas emissions that come from the combustion of hydrogen. The question is, can the current meters that we have in place handle this without having to go redo the whole infrastructure of the piping, of the pipelines that are in place now in the measurement stations? And the answer is up to a certain point. We can go up to about 30% hydrogen electrically, and probably 20% just as far as the uncertainty and the ability of the meter to measure the gas properly, the way things are set up right now. Down the road, when those hydrogen levels become higher, we'll have to look at changing equipment, maybe look at changing the sensors, those kind of things. The blending of hydrogen has become a big question, and a lot of the end users that we've had in the past have bought thousands of ultrasonic meters that are currently in use today. So their question to us was, how much hydrogen can we put into the gas for it to actually continue to operate correctly and measure within a certain uncertainty band? And so the testing we've done has shown roughly between 20 to 25% is kind of the area where we'd like to see that blending come in. You go higher, all of a sudden the gas starts to act differently. The response to the meter is different. Anything lower and the meters basically repeat the way they have in the past and maintain their accuracy. The ultrasonic group has taken part in a number of GIPs, joint industry projects, where they've actually taken the meters, put them into an environment where they've slowly blended the amount of natural gas and hydrogen in. And the one main test we did was in 5% increments, 5%, 10%, 15, all the way to 30%, just to see what the meter performance would be. The 30% is the level of electrical approvals we have at this point. It's a Group B, or Group C, sorry. We need to get to Group B, so it's a whole redesign of the electronics to be able to go to those environments. Work done by SoCalGas and a number of other different companies showing that roughly 20% is the range where we can use the equipment we have today for compression, line heating, and then eventually when it goes into the consumer's homes, on the burners, on their stoves, furnaces, hot water tanks, and everything else. So that's kind of the level we're looking at right now. And I think what most people or most companies are kind of aiming for is to roughly 20% by volume. The volumetric components of hydrogen are quite a bit lighter, so you need quite a bit more volume. So the limitation is going to be the maximum speed that the gas has to go at to deliver the same amount of energy that it did in the past. With the requirements coming up for blending and distribution systems, pipeline systems, and even to small industrial users, Emerson's very well positioned with all the products we currently have. With the ultrasonic meters, with the testing we've done, we can measure the gas in higher pressures. The Coriolis meters allow us to measure smaller line sizes plus do injection. The analyzers we have can analyze hydrogen. And then the valves and the peripherals that go along with that are all well positioned as well. So as far as the entire package, we're well positioned, and we've already proven that by putting together packages for some of these blending applications. There are certain limitations to what the ultrasonic meters can do. Initially, it's going to be the electrical approvals, which we discussed in the past already. Once we overcome that hurdle and be able to get a Group B to be able to go to 100% hydrogen, we're going to find that the amount of hydrogen that has to be moved to keep the same energy level that we're getting from natural gas now is going to be 4 to 5 times higher than it was before. So a velocity of 100 feet per second that would deliver enough gas will now have to be 400 to 500 feet per second. And those are limitations. Those are velocities we've never ever gone to. And it won't be just a limitation on the meter, it'll be a limitation on the actual pipeline infrastructure, because when gas moves that quickly, there's a lot of other things that happen to the pipe. There's vibration, there's erosion, there's the rest of that can cause issues. So it's a learning process for us right now, and I think what we'll find over the next 1 to 2 to 3 to maybe 5 years is that exactly what's going to happen and how we're going to be able to move as much hydrogen as we possibly can without having to change major infrastructures in North America and the rest of the world. The move to hydrogen blending and the use of hydrogen to reduce greenhouse gas emissions is inevitable, and Emerson's positioned themselves well with all their different divisions. So for the Rosemount, for the ultrasonic meters, we've done our testing, and we continue to do that, the due diligence to prove that the meters will work. Coriolis meters, Micromotion, has been measuring hydrogen for decades, and they're doing the same thing, just position themselves well as the Fisher valves, and then all the other periphery, the analyzers, the temperature and pressure transmitters, everything else are all going to be ready to move into the hydrogen era. And to find out more about our capabilities for hydrogen, you can go to emerson.com, and there's a number of different studies done on all the different products, on the industry in general, and everything can be found right there. For the Rosemount Ultrasonic meters, it's the Rosemount page. For the Coriolis meters, it'll be Micromotion. For the valves, it'll be Fisher.